Okay, so in this video we're going to look at example number 8. Remember, this is using compound angle identities. This is part of the grade 12 curriculum, although some schools may do it in grade 11 as well, and that's never a bad thing. So I'm going to give you the question as sine of theta minus 45, and as you can see 45 degrees is very useful because it is a special angle. Is equal to sine of theta minus cos theta over root 2. Sine theta minus cos of theta over root 2. And that's what we got to try and prove. Okay, so very, very simple. I'm going to start with this side over here, which is the left-hand side. Okay, and I'm going to note that left-hand side is equal to sine of theta minus 45 degrees. The moment you see 45, it's an angle that's supposed to make life a little bit easier because it's special, and you should know the identities for it already. That is equal to sine, cos, sine, using the compound angle identities. This is minus, and I got to put down a minus as well, and I got to put in my angles. It's theta, that's 45 degrees, it's theta, and that's 45 degrees. Okay, now knowing special angles, we can simplify this. That remains sine theta. The cos 45 is actually root 2 over 2 minus cos of theta, and sine 45 is also root 2 over 2. Sine 45 and cos 45 are actually co-ratios, and that's why they have the same value. Okay, so now I take that out as a common factor. That's one option. Where's this now? I take that out as a common factor, and I've got root 2 over 2 multiplied by sine theta minus cos theta. Okay, now what's important to note here, I'm going to change root 2 over 2 into a non-rationalized root form, right? Because root 2 over 2 is exactly the same thing as saying 1 over root 2, okay, multiplied by sine theta minus cos theta. And when you multiply that out, this thing here, 1 times this thing over here, this 1 times this over here, remember this is also a fraction, it's going to give you sine theta minus cos of theta divided by root 2. And therefore I can conclude that that is the right-hand side, right? I'm technically done over here, but I think some of you are wondering, is this and this really equivalent? So let's show you that this is just the same number, right, expressed in a rationalized denominator form. So 1 over root 2 is really equal to root 2 over 2. The question is how? And let's show you. Well, start off with 1 over root 2 and then multiply it by root 2 over root 2. Now, I hope that you agree with me at this point in time to say that root 2 over root 2 is equal to 1, right? Because it's the same thing. And then when you times the top by the top, you get 1 times root 2 is just root 2, and root 2 times root 2 is just root 2 times root 2, which is just equal to 2. And that's why we can say that this thing is equivalent to this thing, because I've multiplied it by 1 in order to just rationalize the denominator. Okay.